Welcome to video 4. Hopefully this is the final video of the day and I don't make any more mistakes. So this last section is really all about a variety of techniques, and most of these techniques we've looked at over the first day and a half of notes. We'll go ahead and emphasize some here. Number 4, I think we can identify the most difficult side as the left side, and as a couple of examples previously, this thing follows the difference of squares. I've got the same two terms inside the parentheses, but one's a minus and one's a plus. So if I multiply these, if I remember what the difference of squares looks like, this becomes cosecant squared theta minus 1. I'm betting that's a Pythagorean identity, and so I pull up my trusty pink sheet. I'm looking for cosecant squared minus 1. And sure enough, it's right over here. And we're told that according to Pythagoras, it should be equal to cotangent squared. I'm now at cotangent squared theta, which is exactly where I wanted to be, and that's the end of this problem. Number 5, I would like you guys to try, help those around you. The beginning hint I will give you is that you should try to distribute first. Example number 6 is a combination of all the strategies that we've used. Right away, I pick a side. I'm going to pick, you guessed it, the right side. I get excited about the right side because I have a couple of combinations of squares and ones. And if I refer to my pink sheet again in the third section, I notice that 1 plus tangent squared is secant squared. And then cosine squared minus 1 is negative sine squared. I can then use a reciprocal identity on this one, and I get 1 minus cosine squared. I multiply that by the negative sine squared. I can combine them into a single fraction. And then I can use my quotient identity, that's the very second section, and I end up with negative tangent squared x, which is exactly where I wanted to conclude. Number 8, I would like you all to try using a Pythagorean identity. Good luck. Number 9 can be factored, and I would start with the right side. That's the difference of squares. Number 10, I would like you to start with the Pythagorean identity. And number 12, I would like you guys to work through with me. So number 12, I'm going to start with the left side. It has a combination of operations here. It's got a big division bar, it's got subtraction. I think that's more complicated than the right-hand side. One of the things that you can do on these problems is really look at where the problem starts and where you want to finish. I do notice in this problem that I have a cosine in the original problem, and I want to somehow get rid of that. The only function that I want to have at the end is a sine function in the answer. From my Pythagorean identities, I can pull out that cosine squared x is equal to 1 minus sine squared x. And my denominator stays the same. This numerator also follows the pattern of the difference of squares, and I can factor it. Which leads me to be able to cancel, and I'm left with 1 plus the sine of x, which is what the problem was asking me to prove in the first place. So this concludes the final video. I hope that I've given you enough information to be able to try some of these problems that we skipped and also to complete your assignment. I will be back on Wednesday. Good luck.